Hello children. In the previous session of mathematics, we were discussing on the lesson quadrilaterals. We have already studied what are the properties of quadrilateral, which are the types of quadrilateral and its properties as well. And also we have studied various theorems and solved the last exercise, that is exercise 7.1. In today's session, we shall study one more new theorem called the midpoint theorem, which is very important, and also solve the last exercise of this lesson, that is exercise 7.2 children. So before starting with the exercise, let us understand what is this midpoint theorem. You have the last two theorems of this lesson, that is theorem 7.9 and 7.10. As I already said you, the proofs of this theorem is been removed and you will have to remember only the statements of the theorems, children. This midpoint theorem statement is theorem 7.9. The question may be, though the proof is not there, children, please don't neglect these theorems. The reason is this is very much required in order to solve the problems. Without this concept, you cannot solve the problem. As you all know already, since you have solved the various problems in geometry. Now children, the statement states that, this is midpoint theorem statement. The line segment joining the midpoints of one side of a triangle is parallel to the... So now we shall read the statement that of the midpoint theorem or theorem 7.9. It states that the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Very simple. We will read it again. The line segment. So there should be a line segment, or the line segment is a line joining the midpoint of two sides of a triangle. So we know in any triangle there are three sides, three vertices, three angles, and angle sum property, everything we know, children. So on any two sides of a triangle, if at all you mark the midpoints for those two sides and join those midpoints by the line segment, then the line segment which you draw is parallel to the third side anta heluತ್ತೆ midpoint theorem andre. Now children, as you all can see, here is triangle ABC with vertices A, B and C, and which are the three sides of the triangles, means side AB, side AC and side BC. Now let us consider the side AB and side AC of this triangle ABC. Roughly, I am marking the midpoint of this side AB and label it as, say, E. Now E is the midpoint of the side AB of the triangle ABC. Hope you are understanding. Roughly, I am marking midpoint for the side AB of the triangle. Similarly, I will mark the midpoint for the second side of the triangle, that is AC, and call it as F. Now what we have done? The midpoints of the two sides of a triangle we have marked already as E and F. Now let us join those midpoints. Andre hige. We joined the midpoints of the two sides of the triangle EF we got, which is the line segment. So the line segment, what they mean here is this distance EF, children. So the line segment joining the midpoints of the two sides of a triangle. Andre the line segment which is joining the midpoints of the two sides of the triangle is parallel to the third side. What it means is, the new line segment EF, what we got, is parallel to the third side of the triangle. Which will you consider as the third side? Of course, the base BC of the triangle. Why? Because for side AB and side AC we have marked the midpoint and joined the line segment, children. So obviously this, what the line segment which you connected by connecting the midpoints of either side of the triangle is parallel to the third side. So EF is parallel to BC. That's all states the midpoint theorem. Now the last theorem of this lesson is theorem 7.10, which is nothing but the converse of midpoint theorem. It states that the line drawn through the midpoint of one side of a triangle parallel to the other side bisects the third side of the triangle. What we did in first case is, For the triangle ABC, children, we mark the midpoint for the two sides. Now what they are saying is, if at all you mark any midpoint for any one of the side of the triangle and just draw the line segment such that it is parallel to the second side of the triangle, then the one more point is there now of the line segment started from E that will bisect, andre it will touch the other side of the triangle at F anta artha. It is just the converse. ಈಗ lines midpoint ಇಟ್ಬಿಟ್ಟು line segment draw ಮಾಡಿದ್ರೆ line segment to parallel to the third side is midpoint. The converse of that is, if at all we mark any midpoint and draw the line segment which is parallel to the second side, then the other midpoint will bisect the third side. The line drawn will bisect the third side. So now we will read it again. The line drawn through the midpoint of one side of a triangle which is parallel to the other side bisects the third side. ಅಂದ್ರೆ ಅದರದ್ದು midpoint ಆಗ್ತಾ ಇದೆ, ಯಾವುದು F ನ ಮಾರ್ಕ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಅಷ್ಟೇ. This is about the midpoint theorem and its statement. As I said, your proof is not there, children. So though proof is not there, I may ask you state midpoint theorem. In that case, you will have to remember this statement and also explain it with the help of figure and write this EF is parallel to the third side of the triangle BC, children. That is what I expect from you. So please learn this statement. Or if state the converse of midpoint theorem may also be asked. In that case, you will have to remember this statement. Hope you have understood the theorem. So with this background of midpoint theorem and its converse, based on this concept only, you have the complete exercise 7.2, children, which we shall be solving now. With exercise 7.2, the first question says, ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that in the first case we need to prove SR is parallel to AC and SR is half of AC. PQ is equal to SR and PQRS is a parallelogram. All these three cases we need to prove. Before starting with this problem, children, I want to tell you one important point about the midpoint theorem. Now you have understood in the midpoint theorem that if you consider a triangle, any triangle ABC and mark the midpoints E and F and join those midpoints by the line segment, then that line segment is parallel to the third side of the triangle. And one more thing you keep in mind, children, along with that you remember also that this new line segment which we drawed by joining the midpoints, that line or that line segment is exactly half of the base third side. That is, EF is half of BC. This you please remember, children. I forgot to tell you. EF will be half of BC. Anta nanpitkolli. That concept is required here. So this is the given figure. You have a quadrilateral ABCD. So for all the four sides of the quadrilateral, the midpoints are marked. For the side AB, P is the midpoint. For the side BC, Q is the midpoint. For the side CD, R is the midpoint. And for the side DA, S is the midpoint. Now all the midpoints are joined and we got one more quadrilateral inside ABCD, that is PQRS is the new quadrilateral which we got inside. And AC is the diagonal drawn. We know, children, that whenever you draw the diagonal to a quadrilateral, it will divide the quadrilateral into two triangles. This concept you know. Now they are asking us to prove that PQRS, the inside quadrilateral what is formed by joining the midpoints of the outer quadrilateral, is a parallelogram. In other words, we need to prove PQRS is a parallelogram. That is the third case. In the first case, they are asking us to prove that SR is parallel to AC. This SR is parallel to AC. What is AC? It is the diagonal of the quadrilateral. SR is the line segment which we got by joining two midpoints. So SR is parallel to AC and we need to prove. Now children, consider only half of the figure. Andre up to this diagonal AC you consider. I will draw it for you if you want. It is something like this. A triangle you will get. So this is your diagonal AC which I have drawn as the dotted line there. Okay, now if you want complete line and draw madi. AC ಇದೆ, ಇಲ್ಲಿ ಮಿಡ್ ಪಾಯಿಂಟ್ S ಇದೆ, ಇದು D, ಇದು R, and this is joined. Can you apply the midpoint theorem now? That is what we will do. ಅಷ್ಟೇ. ಈಗ ಈ ಫಿಗರ್ ಅಲ್ಲಿ ನಾನು ಜಸ್ಟ್ ಏನ್ ಮಾಡಿದೆ, ಇನ್ನೊಂದು ಫಿಗರ್ ಬರ್ದೆ, ರಿಮೂವಿಂಗ್ ದ ಸೆಕೆಂಡ್ ಹಾಫ್ ಆಫ್ ದ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್, ದಟ್ ಈಸ್ ಡಯಾಗನಲ್ AC ಅಬೌವ್ ಏನೇನಿದೆಯೋ ಅದನ್ನ ಮಾತ್ರ ಐ ಡ್ರಾನ್ ಚಿಲ್ಡ್ರನ್. ವಿ ಗಾಟ್ ನಥಿಂಗ್ ಬಟ್ ದ ಫಿಗರ್ ಆಫ್ ಮಿಡ್ ಪಾಯಿಂಟ್ ಥಿಯರಮ್, ಅ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ವಿತ್ ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಅಂಡ್ ದ ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಇಸ್ ಜಾಯಿಂಟ್. So no need to worry at all, or any difficult proof is not there. In triangle ADC, so we got triangle ADC there, isn't it? Even you can draw that for reference. S and R are the midpoints of the side AD and DC respectively. So according to midpoint theorem, what you can say, SR is parallel to AC, and obviously just now I said no, SR is half of AC, so first part is proved. SR is parallel to AC, SR is half of AC. Reason midpoint theorem inda we know ashte. Second concept alli enu andre, similarly they have considered the part of the quadrilateral which is below the diagonal AC. Andre you have this part, that is AC is again the diagonal, you have B and P and Q are the midpoints, so you have joint ashte. In triangle ABC, that is what I have started. In triangle ABC, P and Q are the midpoints of the side AB and AC. From midpoint theorem, side AC is parallel to side PQ, and obviously PQ is half of AC. Ashte ಇನ್ನೇನು ಇಲ್ಲ. So hang prove ಆದ್ಮೇಲೆ I ask for something else. We need to prove PQ is parallel to SR. ಯಾವುದು PQ? ಇದು PQ is parallel to SR anta. In first part, first sub question, we have proved SR is parallel to AC. Idan tolana. We have proved SR is parallel to AC. So side SR is parallel to AC. In the second part, we have proved PQ is parallel to AC. Andre, look, this PQ is parallel to AC. You have studied in Euclid's axioms. If equals are what if equals are added to equals, the whole are equal antara. Hangene children, SR is parallel to AC, PQ is parallel to AC, andre obviously PQ is equal to RS or parallel to RS anta. That is what is required in second sub question. Andre nimge idu artha agilla andre what you do is, first case alli we have proved SR is equal to AC. Second case we have proved PQ is equal to AC children. AC is common. If you cancel, what you get is SR is equal to PQ or PQ equals RS. That's all we did. That is about the second sub question. In the third sub question, they are asking us to prove the inside quadrilateral PQRS is a parallelogram. Very simple. Just now we proved PQ is equal to RS in equation 2. That is what we wrote here. We proved that PQ is equal to SR. Also we have proved SR is parallel to AC and PQ is parallel to AC in second sub question. Therefore SR is parallel to PQ now. If SR is parallel to PQ, which is the one of the pair of opposite sides of a quadrilateral, then obviously PQRS is a parallelogram. That's all. That is about the first problem. So easy, you know, if you know the midpoint theorem, these 3 sub questions in a minute you can solve, children. So please understand the theorems and also learn how to apply it practically. That is important. That is very, very important. Next we shall solve the second problem.